Hi, this is Mike Mulholland, and today we're going to be looking at a trigonometry question about directions and distances. So here's the question. We've got radio direction finders at points A and B, 8.68 miles apart, east-west line. From A, it's found that the signal from a transmitter at C is a certain angle, and from B, it's a different angle. Find the distance of the transmitter from one of the two direction finders. Now, the first thing we need to do is to understand the directions, because bearings like this are not the way we normally talk about angles in trigonometry. So this is how bearings work. The first letter is an N or an S for whether the direction is relative to due north or due south. And then we see how much the direction differs from, in this case, true north, because that's an N. And then we see how much the direction in which it differs. In this case, it's to the west of north. And in the other one, it's going to be to the east of north. So the last letter is always an E or a W. So this is what this thing looks like. So here's our angle, 54.3 degrees east of north and 35.7 degrees west of north. You know that this is 8.68 miles. We want to know that distance. So we're going to be dealing with this triangle. It's trigonometry. We need to find out more about that triangle. So first, let's figure out the interior angles. So this one, we subtract 54.3 from 90 to get this, and we get 35.7. This one, we subtract 35.7 from 90, and we get 54.3. The same pair here and here. And that's because the person who wrote the problem chose these two angles on purpose to add up to 90 degrees to make the problem easy to solve. So this and this add up to 90, so that is 180 minus 90, or 90 degrees. We have a right triangle, so we can use our trigonometry functions. So again, updating what we know and only showing the parts that we need. So we have a couple of options here. We know, we want to know this side, we know that side, and we know this angle and that angle. So if we look at it from the point of view of this angle, looking that way, then then we want to use the function that is opposite over hypotenuse, which is the sine. And if we look at it, we're standing here looking this way, then these sides are adjacent over hypotenuse, because again, we want this one. And so then we look at the cosine, but of a different angle. And so the sine of this angle is the same as the cosine of that angle. They have to be, because they're both the ratio of the length of this side over that side. So in either case, we get that 0.547 equals the length of BC over 8.68. So we multiply those two together to get BC, and we find that that distance is 5.07 miles. Now, was that plausible, just looking at it? If that's 8.68, for that to be 5 point something, yeah, that looks very reasonable. This should be somewhat shorter than that, maybe 5 or 6 miles. It makes sense. But like I said, the person set up this problem to make it very easy for you by making the two angles here add up to 90. But how realistic is that? If you inscribe an angle inside a semicircle, which is what that person did, then the angle is guaranteed to be 90 degrees. If we did the same thing here, over to there, that angle would be 90 degrees. But that means the solution that we worked on, the method that we used, would only work for points that are on this circle. But that's not very realistic. In real life, you'd have some points outside the circle, some points inside the circle, like this one. So I made up an example how we can solve this, which is much closer to what you might see in a real world example. So we are gonna get some right triangles so we can use trig. So we drop a vertical from C down onto line AB. And these are the angles that I specified. We want to determine the length of line BC, which I'm calling X. Now we have some things that we know. What do we know about Z? We know it's the same for both triangles because they have a side in common. And what do we know about Y? We know that plus this add up to 8.68. So now we start to work with that. And let's start with the facts about leg Z, see what we can figure out. So in that triangle, we have the tangent of 40 degrees is opposite over adjacent, which is Z over Y. So we solve for Z, tan 40 times Y, or 0.839 times Y. In the other triangle, the one to the left, we have 20 degrees equals opposite over adjacent, where opposite again is Z, and the adjacent is 8.68 minus Y. So we figure out what tangent of 20 degrees is and multiply it out, and we get 0.364 times 8.68 minus Y. So now we have two different functions of Y that equal Z. Z equals this, Z equals that. So they must equal one another. So we put this equals this. And then we multiply this part out. And then we subtract 3.159 from each side. Let's see. Now we leave that there, subtract 0.364y from that, and we get 1.203y equals 3.159, and solve for y, and we get 2.626. And that looked reasonable from what we remember of the picture. And now, and I went through this a little fast, and I may have made a mistake, but if you just pause it, look at it, you'll be able to figure it out. I may have made a mistake in the description. I did not make a mistake in what's actually written here. And now we can readily determine Z, since we know that Z equals tan 40 times Y from up above. So we plug things in, and we get 2.203 for Z. And it turns out we actually didn't really need to calculate Z, because once we had Y, we had enough. Cosine of 40 is adjacent over hypotenuse. That's Y over X. So solve this for X. X over here, cos 40 down there, under Y. And so substitute the actual values, divide it out, 3.428. Which again is reasonable. That's the hypotenuse. It needs to be the longest of the three. So we now have all three lengths, and just to be careful, just as a check on our work, what we can do is plug them into the Pythagorean theorem, and we got y squared plus z squared, the vertical and the horizontal, it is 11.76. And x, the hypotenuse squared, is 11.76. So it checks with Pythagorean theorem. So we're pretty sure we have the right answer. They look reasonable on the diagram, and that checks out. So I want to thank you for watching, and take care.